Hello, everybody, and welcome to episode number 102, in which we're going to explore the Mutual Authentication Lab for that we've actually just announced as part of the 114 release. So, let's kick off the way we normally do. It's good to see you all out there. If you are present in this video chat, definitely let me know in the comments, and let me know if you want to explore this with me, because I think we should be able to do it simultaneously. We should be able to kind of do that kind of together, which would be pretty fun. Let me share my screen here. There we go. So these are our notes for this week. I'm going to go ahead and share them. 102. So as usual, if you want to see these notes or interact with them or follow any of the links on them, you can access those notes just by going to that link down below on the right-hand side that says hackmd.io/@echo-live, and that will take you to the published notes, and you'll be able to see episode 102 in that list. Let's kick off with eBPF Summit is coming right up. I'm looking forward to hosting this one remotely with my good friend Liz. We have some awesome featured speakers. Sorry. Joe Stringer is going to be joining us. We have Gene Yang, head of product observability at Postman. We have Brendan Gregg, Intel fellow and performance engineer. He's going to be coming to join us. We're going to be doing another CTF. I'm really looking forward to this one. Should be a lot of fun. If you're interested in understanding what we were up to at last year's summit, this is actually where you can go find information about it and check it out. But for this year, we're coming up on September 13th, 2023. Should be a lot of fun. We'll be doing it from 8:30 a.m. to 12:30 p.m. Pacific time. So definitely come check it out. And you can register for it right here. So if you're checking it out, definitely go register for it. The call for speakers is closed at this point. We have an incredible lineup. Definitely come and join us. The news for this week, I was excited about this. A good friend of mine reached out to me and said that he had, I must have typoed something. There we go. He had written an article about eBPF, and I told him, hey, you got to go share that with Bill Mulligan so that he can share it with the community. And this is the article in specific. Past week, Wiz blogged about the overlay bugs that can be abused on Ubuntu's kernel to perform privilege escalation, namely the game overlay. Read more here. It's actually a number of interesting CVEs related to it. All these are mostly the same. The overlay FS can be mounted inside of a user namespace, but the security checks and value validation when copying files up and their metadata from the lower to the upper layer in the user space were not sufficient. As software evolves, such things can happen. So this was a Tetragon solution to actually make sure that we were securing that particular piece of it. So looking for the information that actually matches it, and then making sure that we're able to catch it. So very cool article about how to actually use tools like this to be able to secure things like overlay FS privilege escalation. So this was written by Al-Harani. So thank you so much for putting this out there, and it's a tremendous good link, and actually really an interesting challenge that, like, most security and infrastructure has in this sorts of scenarios where, like, the world is kind of changing constantly. So when these things happen, it's pretty tough to solve. Other stuff in this newsletter, obviously, Cilium 114 is out, and with each release, it's becoming more clear how Cilium is just becoming the full connectivity solution for it. If you want to check out the blog post for Cilium 114, you can go to isovalent.com/Cilium blog, and you will find the incredible new blog post. I love these blog posts because they really get into detail, right? So like each of the bullet points that we're highlighting here, you can just click on them and navigate to them and check them out. The big one for me in Cilium 114 is this piece right here, mutual authentication, which is what the lab is for. And that's the lab that we're going to explore together here in this episode. Some of the other stuff that's exciting is that we have now the capability of deploying an Envoy daemon set separate from the Cilium agent itself. And this is something we've been thinking about for some time, but it's now possible with the Helm chart. We got some changes to the WireGuard implementation within Cilium. So before, WireGuard was really just being focused on solving the pod-to-pod encryption, and now with these changes, we also support node-to-node encryption. I believe that's actually that you can actually walk through that implementation in one of the labs that we have. And if you click on any of these more details, you're going to find information about the changes, and then you'll also find a lab kind of showing those changes. So pretty exciting stuff. If you want to be up to date with what's happening in the space, definitely come check it out. An incredible article by the VM blog expert talking about the changes necessary to be able to support mutual authentication in isovalent, verifying the verifier, so watching the watcher, as it were. So eBPF range analysis verification. We've discovered new bugs that prove the soundness of range analysis in the latest version of the Linux kernel. How eBPF improves observability with Kubernetes. Sec import, Python runtime sandbox with eBPF and SecGo. The public comment period is open. I'm super excited about this, but the public comment is now open. So if you wanted to come check, if you wanted to make comments on the graduation of Cilium, definitely come check that out. Very exciting. What else is happening? Install Kubernetes 127 with Cilium on Ubuntu with 3 workers on a master node. See how they're going about this one. So this is what do we need? 4 virtual machines, a bridge network, Vagrant. Nice. How are they going about it? Looks like they're just bringing up everything kind of by hand, really. And then, so they're going to use kubeadm to do the formation of the cluster. Yeah, it's a good learning exercise. Bringing up a control plane node and 3 worker nodes, and then installing Cilium and showing how all of that works. So pretty cool. Good learning exercise. Enabling Hubble. Yeah. So definitely check that out if you want to learn more about Kubernetes and with Cilium. Our most talked about feature now has a video. I'm not going to play that for you, but it's an exciting one. It's like, oh, boop. So one of the more exciting features that's coming in 114 is mutual authentication. Definitely check this out if you want to watch it. It's a minute 48. There's also a recent eCHO office hours where we talked about it on where Thomas and Liz explored the technology and why it's so key to the success of the 114 release. All right, and I believe that's actually here. Yeah, that's linked from the newsletter as well. So if you wanted to check that one out, it also has Marta in there as well. So very exciting. Okay, let's get started with the lab. If you want to join me on this adventure, I've actually made a couple links. Like, first of all, the docs for MTLS are in beta. It's all here on how to actually go ahead and set it up, like talking about the design of it, getting into some of the detail. I'm not going to spend a lot of time on this myself because I'm actually planning on doing the lab. But if you wanted to explore it, there are some great details in the documentation for it. You've seen the blog post. Another thing that I really appreciate about working for Isovalent is that a lot of the changes that we're going to make in the CNI, a lot of those things that we're doing to advance the technology, you're going to be able to see those things come out previously in talks. So, for example, here's a seamless, transparent encryption with BPF and Cilium Linux Plumbers Conference 2019, in which John is talking about leveraging MTLS encryption with Istio Envoy, Cilium Envoy, and Cilium Envoy and SOCMap. And so this is like an exploration into how we can go about solving these problems, probably, a couple of years before we actually ended up solving them in the product itself. So very exciting stuff. Definitely go check those out. Let's get started with the lab here. So If you want to follow along and do this with me, here's how you would go about it. You would go to isovalent.com/labs. And inside of here, you're going to find a lab that says Mutual Authentication with Cilium, new, earn a badge, which means that after you get through this lab, if you have passed all of the challenges, you're going to receive a badge for accomplishing this test or accomplishing this lab. I have the lab spun up right here. I've actually just gone through and clicked, entered my information and hit submit. We need this information to be able to send you a lab, of course. And there's also more information about the privacy policy and occasional emails, etc. So to view the lab notes, let's go through here and check these out. So new to network, Cilium and network policies. If you're not familiar with Cilium and network policies, we recommend that you take the Getting Started with Cilium lab first. In the Getting Started with Cilium lab, you will implement advanced layer 3 and layer 7 network policies in a Star Wars inspired scenario. And by the end of the lab, you will have enforced strong network policies and protected the Empire with microsegmentation against attacks from the Rebellion. There's another one that's a longer one that I really, really like, which is the Zero Trust lab. And that one takes you through how can you take a cluster or a namespace or a deployment, however you want to think about it, from zero network policies to completely securing all of the traffic and in such a way without actually accidentally cutting off traffic for all of those applications that are operating. Because Cilium is so native, has observability in such a native way, we can actually iterate through policies and continue to add policies until we have all traffic matching policies. And then we can remove the allow all rule that allows all traffic within a given namespace or between namespaces. So pretty cool lab. And that lab is called the Zero Trust Lab. I'll show you where that one is real quick, but it's really great. Let's see, Zero Trust. There we go. It's Isovalent Enterprise for Cilium, Zero Trust Visibility. So this one right here is a really good one if you want to work through that. So in this lab, we're going to be studying about Star Wars demo, but in addition to network policies, we're also going to learn how to enforce mutual authentication between workloads. The Empire needs mutual authentication. And basically, what this allows us to do is not just make decisions about whether endpoints can communicate with us in a network policy way, but we're also going to say that when those endpoints can communicate with us, we want to ensure that on the wire, all traffic is encrypted. So that if there's anybody snooping into it, they cannot see any of that. They cannot understand that traffic. So similar to Google's application layer transport security, Cilium's MTLS-based mutual authentication splits the handshake protocol and the record protocol apart and performs that handshake out of band of the actual packet flow. What that means is that we're not actually providing keys to an application to encrypt its own traffic between endpoints. We're doing this in such a way that we're ensuring that all traffic between these applications is going to be encrypted outside of the flow of the application itself. We're not requiring that the application do it. We're doing that on our own. The MTLS authentication layer of Cilium fulfills the authentication requirement of a connection, whereas the existing in-kernel encryption layer provides confidentiality and integrity properties to the connection. So if you require authentication as part of it, the MTLS piece will actually handle that for you. To learn more about encryption on Cilium, check out the Transparent Encryption Lab. And you can actually also look at previous eCHO office hours in which I explored Cilium and WireGuard encryption. This lab is going to focus on mutual TLS. Some of the benefits of Cilium's mutual authentication layer versus some of the other ones that we've seen out there, the implementation of MTLS authentication is simplified as it can be rolled out service by service easily. So instead of thinking of it like everything has to be at this layer, we're saying that some services can and some services cannot participate. And any network protocol is supported, right? Where we're not actually limited to TCP. So UDP traffic, whatever type of traffic it is, can be encrypted in this way. The secrets used for authentication are safely kept away from any L3 and L7 processing, and this resolves a significant attack vector when found in L7 proxy-based MTLS. Key rotation for authentication and encryption can be performed on live connections without disruption. And when you're done, you'll get a badge that looks like this, Mutual Auth. If you haven't explored Instruct before, we have a little video here to show you how it works. But let's go ahead and get started. Oh, mine expired. Hold on one second. Give us just a minute here. Wish I'd clicked on that one earlier. I'd forgotten. Welcome, Sadiq. Good to see you. Connecting to us from LinkedIn. Again, if you're in the audience, definitely let me know. I'm always happy to see folks out there. And if you want to participate in this lab with me, how you would go about it is you would go to isovalent.com/labs, and then you would click on the Isovalent Mutual Authentication with Cilium lab. This is the one that we're going to be exploring today. So if you want to explore that with me, you can just click on that and enter some information, hit submit, and it will take you to the lab that we're about to explore. Hamsters in overdrive. While this is loading up, I'm actually going to grab some water. I'll be right back. All right. Almost there. 40 seconds. I'm going to be able to get started. Hey, Conrad. Conrad joined me for the security summer school that was actually happening. I didn't realize you were in San Francisco. I'm in Alameda. I'm not far away at all. Good to see you. We just got done with a series of events called Security Summer School, in which we were doing something very similar to this, exploring a lab with folks. And Conrad was part of it. So verify Cilium installation. Cilium was installed during the lab boot up and was deployed with the following Helm flags: Authentication Mutual, port 4250, Spire enabled true, install enabled true, and namespace Cilium Spire auth. This enabled the mutual authentication feature and automatically deployed a Spire server. If you're not familiar with Spiffy and Spire, don't worry. We explain these concepts behind Spiffy and Spire and how they integrate with Cilium in a later task. Just know that Spiffy is an identity framework. It stands for Service Production Identity for everyone else. And securing communications between microservices, while Spire is production-ready implementation of Spiffy. Verify that mutual authentication was enabled. So let's take a look. Cilium config view. The mesh auth enabled true. Mesh expire GC interval 15 minutes. Looks like everything is looking like it's wired up here already. So we can see from the above that mutual authentication is enabled. The port where mutual handshakes between agents will be performed is set to 4250 by default. The Spiffy trust domain is set to spiffy.cilium by default, and the Spire connection timeout is set to 30 seconds by default. Note that this default Spire settings can be customized at deployment. So if you had a different domain that you wanted to make use of within this cluster, that's something that you could absolutely do. Note that while mutual authentication has been enabled globally, it won't apply to workloads until a network policy is applicable to those workloads. Authentication mode required setting. You will learn more about this in the upcoming test. Oh, look, typo. Oh, gotta get that fixed. Let's also debug log level, so as this will be useful to show the actual mutual authentication later on. So let's go ahead and copy this, paste it in. And what that's going to do is it's going to change the config to enable debug, and it's going to restart all Cilium pods. It looks like we're almost rebooted. There we go. Let's do our check. So the next step in our journey here is to deploy the demo app. So we're going to deploy the Star Wars demo app that is used as part of a number of our labs. So let's go ahead and get those deployed. And we can see that what is going to get deployed by the first of the YAMLs here, HTTP SW app, is a service called Death Star, a deployment called Death Star, a pod called TIE Fighter, a pod called X-Wing, and then a Cilium network policy, rule 1 called. Let's take a look at the network policy that has been created. So this network policy is an L3, L4 policy to restrict Death Star access to Empire ships only. This is actually one of the examples that we use in that lab that we talked about before, in which we set the endpoint selector to class Death Star and org Empire. We can see which pods are actually associated with that. By running a kubectl get pods with a label selector. How you doing, Max? Good to see you. Welcome here. So if you're ever wondering if you can actually understand what components are matching a particular label set, so this is one way of actually doing that, right? If I do a get pods -a for all namespaces and -l for, and then apply the labels that I want to match, then I can see only those things that actually match that configuration, right? So the only pods in my entire infrastructure, including the default namespace, that match are these ones right here that say Death Star. But what if I wanted to watch for egress? I want to look for only those things that are Empire. Here we can see that that actually applies to the Death Star components themselves and also to the TIE Fighter. And if I wanted to match on something that does not match on that, these are all the things that are not Empire related. So here's the X-Wing, there's the Spire stuff. Obviously, all the rest of the pods of the cluster do not have that particular label associated with it. All right. So this network policy will only allow traffic from endpoints labeled org Empire to endpoints with both the Death Star and org Empire layers over port 80, and as long as it is a TCP connection. So let's check the network policy and verify the connectivity model is the expected one. So first, let's verify the Death Star deployment is ready. And it looks like it is. It looks like it's running fine. Looks like everything's running here. If you're going to verify the TIE Fighters are allowed to land on the Death Star. Oops, I had that selected. There we go. So I do a curl against the Death Star internal service, and I say request landing, and it says ship landed. And then I want to verify that the X-Wing, which belongs to the Alliance, is denied from the Death Star. Let's take a look and see if that works. Nope, no landing for you. That's perfect. That's exactly what we wanted to see. So is this secure? By this stage, the Empire feels like they have established a strong policy model, which should match the model below, right? In which we see things like the TIE Fighter and other components that actually have org Empire can actually communicate with the Death Star. Oh no. I just had a big X reset. It's going to take me a second to get back here. Bear with me for just a moment. Oh, man. Technical difficulties. All right. All right, bear with me for just a moment while I figure out how to get this back. So I've just had a pretty significant impact on my network piece. So give me just a moment and let me remove this share while I figure out how to fix the problem here. I want to use that camera. Tilt this up a little bit. All right, okay. That's the camera. I'm gonna stop sharing for a moment. And I'm going to take a look and see if I can figure out how to make this thing become aware of the world again. Lost all but one of my screens. Oh boy. Still working on it here. Trying to get something back. Let me see if I can actually shortcut the process. See if we can just get one thing working. That might be easier than trying to get all of it to work. Like that. See if that gets us anywhere. Good times. Major problems. Just a few more minutes here while I get this figured out. We will get right back into it. Live troubleshooting. Three, 4, 4, 9, 8. Let me turn off my mic over here for a moment. All right, so here's what I'm going to do. I'm going to bring in my iPad, and then I'm going to have to reboot my laptop to get this to work. So bear with me for just a minute while I bring this guy in. And now you have two of me. And now here's just one. Okay, so I'm going to reboot my laptop real quick and see if we can come back to that lab. So bear with me for just a minute. Hard fail. Okay. Good times. Okay. System settings. Monitors. Try that for a second. Almost there. I think we're getting somewhere. Just a minute more. And no. Wowzers. Yeah, haven't had this much difficulty with a system in quite a minute. So give me just a moment here, and we'll see if we can get continued here in just a moment. Actually, it might be enough. Yeah, you can hear me through this system, which I think is fine. Bear with me here. Pretty significant impact. Nearly there. Just a moment more. I think I'm going to need one more reboot to get it. If you are doing this lab as well as I am, then definitely let me know that you're still working on it, and I'll be along with you here in just a moment. Haven't had this level of problem in quite a while, so I'm gonna have to figure out what caused this. Almost there. And okay. Hopefully this time we will be able to get going here. Otherwise, the technical difficulties might just overcome us, and I will have to restart this again in 2 weeks. But I'd love to get through this. So My goodness. Haven't had a failure this hard in quite a while. Lit up. I just need one thing to work long enough. Man, oh man. Survey says yeah, total failure. All right, friends, that's a wash for today. We're going to have to restart this in 2 weeks. I'm sorry about all the difficulty, but yeah, complete failure on my side. I'm going to have to try and figure out what's happening and get this fixed up. Thank you so much for tuning in, and I hope that I will see you in 2 weeks when we can get this resolved, probably sooner than that, but that's the situation. Talk to you soon. Bye. Oh, wait. I think we might be back. Are you still there, Conrad? I figured out what the problem was. I'm not sure if you're still there. Can you see me? Anybody still out there? Or am I all alone? All right. Well, I think what I'm going to do is I'm going to call it for today, and we're going to proceed with this in 2 weeks. So we'll talk to you all in 2 weeks. Thank you so much for. Oh, you know what? You can't hear me. So I don't know if anybody's still out there, but I did actually discover what the issue was. It looks like I had lost power to my monitors and fixed it. But I think if there's nobody tuned in here, I'm going to let it go, and we're going to do this in 2 weeks because I had already kind of said goodbye in the previous. So thank you so much for tuning in, and we'll see you all in 2 weeks. Sorry about the technical difficulties. Talk to you soon.